Yeah, I would break the ML lifecycle down to four parts. The four parts are data, which it's just anything that's touching data and has nothing to do with models. So that includes feature engineering, analysis of data, etc. Then there's training. I took data, I built training sets that I think have valuable features and my label on it. I'm now going to train the model. Cool. Once the model is trained, you're going to have to deploy it. And in some cases, if it's like a batch scoring model, that might be very simple. In a lot of situations, it's like touching a user, if it's fraud, if it's a recommender system, etc., it's more real time, then it's much harder. So then they're serving. Finally, there's evaluation and monitoring, which is okay. So I built my data set, I trained my model, I served my model. Now my model's in production. I need to make sure it's behaving well and that it continues to behave well because data changes over time. Things change, you want to make sure that the model is continuing to behave well. So those are the four parts. And just to be clear, it's not linear. It's very common to jump back and you're going to be training lots of different models. You might not deploy a model that you trained. It's very common. You might deploy multiple models in A/B tests and you have kind of like special evaluation tools for that. It's definitely more complicated, but the four steps tend to be the same. Let's look at LLMs. So data. If you're doing RAG, which means you're taking external data, it's similar. Like you have these data sets. It could be like a dump of chat conversations you've had. It could be a dump of PDFs, who knows? You're processing them, you're doing feature engineering on them. You see obviously more embedding-based techniques, even though those are used in traditional ML, you see them more in LLMs. And you also see traditional analytical features, as we talked about, from age to average to graphical-based features, etc. And this training, well, LLMs are pre-trained. So you can skip training, but the equivalence of training would be fine-tuning. And when you fine-tune, in my view, it just makes sense to fine-tune. If you can fine-tune, there's almost never a negative of fine-tuning. If you're doing RAG, you can RAG and fine-tune. A lot of people view them as one or the other, but you can very easily do both. So you have external data, you do that. You fine-tune. Now, there's similar problems here about experiment tracking. I'll have all these different fine-tuned models or fine-tuned in different ways. How do I track those? But I need to deploy those. If you're using ChatGPT or OpenAI, it's behind a model, but I'm seeing a lot of people deploying like Llama and other things, especially some of the bigger companies, so they have full control over it. And that's hard. It's actually harder than deploying traditional ML. Because much bigger model, you need to be much more deeply in tuned in how to make your GPUs work well, how to scale those out. GPU sharing isn't really a thing, so you have to figure out how to do that, etc. Finally, there's evaluation. Same thing. You have this model in production, it's serving. You want to be sure you're collecting user responses, even some implicit, like, oh, they read this, or they left immediately, or they asked another question, which kind of implied that I didn't answer the question. Then there's evaluation. Now, those four things are the same, right? It's data, training, serving, eval. In both traditional ML and in LLMs, the things that people spend most of their time talking about are data and eval. Even the hard parts are pretty much the same. Obviously, training and fine-tuning are hard, serving can be really hard, but 90% of papers and things I read or not papers, but blog posts and things I see people talking about in industry are almost always about how do I get my data to do what I want it to do? How do I handle my data? And also, how do I make sure that my model is behaving correctly in production?